Hello, this is Jennifer. Today we're talking about LeetCode 208, implement trie. In my view, this is a very good question. By solving it, we will have a better understanding of this data structure trie. So let's get started. This question asks you to implement a trie with three methods: insert, search, and start with. So what is trie? To make it easy to understand, let's first think about a scenario. Imagine I have a 3-year-old boy named Lucas. Lucas can speak a very limited range of English words. For example, he can only say car and cat. I have been assigned to design a customized search engine similar to Google, but specifically for kids. So let's call it Google. The search results needs to be based entirely on Lucas' very limited vocabulary. For example, if Lucas types CA, the Google search engine would show related words like CAR, car, CAT, cat. This demonstrates that Google is a highly customized search engine based only on Lucas' very limited vocabulary. To implement such a customized search engine, we can use a data structure called a trie. Alright, what does a trie look like? A trie is commonly used for string queries, and these strings are composed of characters. In a trie, there should be 26 nodes, each containing character information from A, B, C, D, E, F, G to Z. For each node at this level, there are 26 child nodes. Each of these nodes represent a character from A, B, C, D, E, F, G to Z. For example, a node containing a character A has 26 child nodes, each representing a character from A, B, C, D, E, F, G to Z. So this node, which contains the character B, has 26 child nodes, each representing a character from A to Z. Similarly, for this node that includes the character C, it has 26 child nodes that include characters from A to Z as well. Imagine this, there would be many nodes at this level, right? This is because each node from the previous level, like a Z, has 26 child nodes. Therefore, we can calculate the total number of nodes at this level. So it should be 26 nodes multiplied by 26 child nodes. Yes, the total is 676 nodes in this whole level. Similarly, each node in the previous level has 26 child nodes. We can calculate the total number of nodes at this level. That would be 676 nodes multiplied by 26. So the total is 17,576 nodes in this level. So our trie is quite large with many nodes. But why do we need to trouble of building such a large tree with so many nodes? What's the advantage of this data structure? To answer this question, let's revisit the scenario I previously mentioned about Google search engine. Take Lucas, my 3-year-old child, as an example. His vocabulary is limited, with most words probably not exceeding 5 letters in length. This implies that if we can construct a trie with 5 levels, we can include all the words Lucas knows. So once we build this trie, operations such as insert new strings, delete new strings, and most importantly, searching for a string in this set are quite fast. While it will use more memory to store, the process of finding a string in this trie will not change, which is a significant advantage. So how to implement a trie? In a standard binary tree, we define a tree node class like this. Each node includes its value, a reference to the left child pointer, and a reference to the right child pointer. Then what about a trie tree? First, it's clear that each node should include its character information. There are also 26 child pointer references, as we mentioned, from A, B, C, D, E, F, G to Z, that need to be stored as well. The question now is, how do we store those 26 child pointers? Yes, I can use an array with a size of 26 to store those 26 child pointers. I also use a Boolean variable named isWord to indicate whether or not it's a word here. What does that mean? For example, for this node includes its character C, which currently has a default isWord value of false. So if I backtrack this path and ask, hey, is C a word? The answer is no. Then I just leave isWord as a false. For this node includes the character A, which currently has a default isWord value of false. If I backtrack this path and ask, hey, is CA a word? The answer is no. Therefore, I keep isWord value as its default false. For this node includes its character R, which currently has a default isWord value of false. If I backtrack this path and ask, hey, is CAR a word? Answer is yes. Then I need to change isWord flag from its default false value to true. All right. Let's go through the process of implementing a trie tree with an insert function together. So first, I will create a new trie node. We just defined a class trie node, which specifies we have an array to store 26 child pointers. We have a Boolean to flag whether it is a complete word. And then the Boolean default value is false. And our current initialization, I set the value of root node of this trie tree to none. Let's say we want to insert the word car into a trie tree. For each tree, we have a pointer reference called root. We copy this reference to another pointer called cur. Now we use a for loop to traverse each character in a given word car. The first letter of the word car is character C. In this if statement, C represents the character we extracted from the above statement, which is character C. So for here, C minus character A means character C minus character A, which refers to subtracting ASCII value of character A from ASCII value of character C. What is the expected results? Yes, we got 2. Which number 2 is exactly the index where character C is supposed to be in this array. Just imagine this array's length is 26. And imagine there are 26 rectangles here. So you can conclude that the pointer of character A should be located at index 0. The pointer of character B should be located at index 1. The pointer of character C should be located at index 2. We use an if statement to check whether this position, index 2, is none or not. Obviously, for this new trie node, each value in the array defaults to none. So if the value is none, it indicates that there is no word starting with character C stored in this trie tree. So I'm going to create a new trie tree node This time, my new Trie node is created with character value C, along with default value is word set to default false, and a default 26 size array to store its children pointers. And this statement means that the reference to this new node should be stored at this specific index. And then we copy this Trie node reference address to the pointer cur. So currently, the pointer cur refers to this node. We will continue our for loop to traverse the second letter of the given word car, which is character A. In this if statement, C represents the character we extract from the above statements, which is character A. So C minus character A means character A minus character A. What are we supposed to get? We got a number 0, which is exactly the index where character A is supposed to be in this array. Obviously, for this Trie node, each value in the array defaults to none, which indicates that there is no word starting with character A stored in this Trie node. So I'm gonna create a new Trie node. This time, my new Trie node is created with the character value A, along with default value is word false, and a default 26 size array to store its children pointers. And the reference to this new node should be stored at this specific index. We copy this Trie node reference address to the pointer cur, so currently pointer cur refers to this node as well. We're going to continue our for loop to traverse the third letter of car, which is R. So for this if statement, C refers to the character we extract from above statement, which is character R. Based on ASCII table we mentioned before, we got the result of 17, which is exactly the index where character R is supposed to be in this array. Obviously, for this node, each value in the array defaults to be none. If the value is none, it indicates that there is no word starting with R stored in this Trie node. So I'm gonna create a new Trie node. This time, my new Trie node is created with character value R, along with default value is word set to be false, and a default 26 size array to store its children pointers. We can store this new Trie node's pointer reference into the index of 17. As I said, I cannot draw the whole array of 26 size here. So we can imagine this is a 26 sized array, and this index is index 17. We copy this Trie node reference address to the pointer cur so that the pointer cur refers to this node as well. Are we gonna continue with our for loop? No, we won't, because we have already traversed each character of the given word car and proceed to the next statement. We need to flag the word we given for that CAR car is truly a word. We then utilize cur pointer. Since cur refers to this node, we can set its is word value from default false to true, which means, hey, we consider car is a complete word in this trie tree. Now, let's try to insert another word that looks new. This word is cat. Similarly, we need to traverse each character of this given word cat. The first character we enter is character C. However, since we inserted a car into this trie tree earlier, the value in the array's index 2 is no longer now. It now stores a reference to this character C's trie node. Then we directly move to this statement. We copy this trie node reference address to the pointer cur. So the pointer cur refers to this node as well. Continue to traverse the given word. The current letter is the second letter of cat, which is character A. However, since we inserted a car into this trie tree before, the value in this array's index 0 is no longer null. It now stores a reference to this character A's trie node. So we directly move to this statement. We copy this trie node reference address to the pointer cur. So the pointer cur refers to this node as well. So we're going to continue to traverse the given word, and the current letter is the third letter of cat, which is character T. For the current node in this array, remember that we use a space located at index 17 to store the trie node reference for this character R's trie node. However, at index 19, the value should still be default, which is now. In case that there are no words starting with E stored in this trie node. So I'm gonna create a new trie tree node. This time, my new trie tree node is created with character value T, along with default value is word set to false, and the default 26 sized array to store its children pointers. So we can store this new trie node's pointer reference into this index 19. As I said, I cannot draw the whole array here. We can imagine this is a 26 sized array, and this index, you can imagine this index is 19. We copy this trie node reference address to the pointer cur. So pointer cur is currently refers to this node as well. Are we gonna continue with the for loop? No, we won't, because we have already traversed each character of this given word cat. So for the next, we're gonna talk about how to implement a trie tree with a search. For example, we want to check if say A is a word. We use a for loop to traverse say A. Current letter is the first character of say A, which is letter C. For this if statement, we ask, is the value in such index is null? Our answer is no. And then we move pointer cur, ensure pointer cur is referring current traversed node. Continue to traverse given word, say A, current letter is character A. So we ask a question, is the value in such index is null? The answer is no. And then we move pointer cur, ensure pointer cur is referring our current traversed node. Are we going to continue our for loop? No, because we already traversed each character of this given word, say A. So pointer cur is pointing to this node. And this node's is word value is false, which means our trie tree define say A is not a word. So we will return cur is word value, which is false. The last section is how to implement start with method. For example, we want to check if CA is a prefix. We use a for loop to traverse CA. Current letter is the first letter of CA, which is character C. We ask the question, is the value in such index is null? The answer is no. We move pointer cur, ensuring pointer cur is referring our current traverse node. Continue to traverse given word CA. Current letter is letter A. We ask the question, is value in such index is null? The answer is no. Are we going to continue our for loop? No, because we already traversed each character for this given word. If we finish traversing each character of CA, we can conclude that there is a start with CA in our try tree, so we can return true. And in the end, we can try to compare these two functions, start with and search. As you can see that they have almost the same code but return different results. In this start with function, if the for loop fully executes, traversing each character of CA, it means we have this prefix. However, in the search function, when traversing each character of CA, we check whether the current node is flagged as is word being true. If it is considered a complete word in this try tree. I hope you like this video and thanks for watching. I'll see you next time.